Our final section of chapter 5 deals with graphing systems of linear inequalities. So a majority of the chapter was spent on systems of equations. Then last lesson, we did graphing linear inequalities. Now we're going to kind of combine those two things to graph a system of linear inequalities. So let's take a look at our first example, where we have to determine whether each ordered pair is a solution to the system of linear inequalities that is shown. So similar to a system of equations, it's exactly the same idea, except now we're not dealing with an equal sign here. We're going to be dealing with a less than, a greater than, or a greater than or equal to, less than or equal to, one of those inequality symbols. But we go through the same exact process. We know that 3 is my x variable and 5 is my y. I'm just going to plug it in, and I have to plug it into both equations, and it has to be true for both of them. So let's plug in that y value of 5. And we'll plug in the x value of 3 into our first equation, and we'll see if it's true or not. We end up getting, for inequality number 1, 5 is less than 2 times 3. So 5 is less than 6, and obviously that's a true statement. Let's try it in the second inequality. Plug in your 5 for y and your 3 for x, and you're going to get 5 is greater than or equal to 3 plus 1. 5 is greater than or equal to 4. And obviously that is a true statement as well. So that point worked for both of my inequalities. So I know that 3 comma 5 is a solution to the system of inequalities. I'm going to go through the same process for my second point. My second point is the point 2 comma or negative 2 comma 0. So I'm going to plug it into my first inequality. 0 is less than 2 times negative 2. Now this is my x, this is my y. I get 0 is less than negative 4. And right away I know that this is not true. Okay, 0 is not less than negative 4. 0 is greater than negative 4. So it didn't work in my first inequality. I don't even have to check my second one. Okay, it has to work in both. So the second that I see that it doesn't work in my first one, I don't need to go any further. I know that negative 2 comma 0 is not a solution to this system of inequalities. So same concept and same idea that we've been doing. We saw problems like this when we were just graphing inequalities. We saw it when we were graphing systems of equations. We just have to plug it in and see if it ends up working, and we get a true statement with our inequalities. We'll look at the try these in class. Now let's talk about graphing a system of linear inequalities, okay? And graphing a system of linear inequalities, like I said, is just smashing together what we've been doing earlier in the chapter when we have a system of equations and what we saw in the last lesson with graphing an inequality. So now we're going to be graphing two linear inequalities, and we're looking for that overlap shaded region here. So you still can have some dashed lines, you still can have some solid lines, just so we remember. Okay, when we have less than or greater than symbols, those are our dashed lines. When we have less than or equal to or greater than or equal to, those are our solid lines. And then to determine if we're going to shade above or below, the less than and the less than or equal to symbols mean that you shade below the line. And then the greater than and the greater than or equal to symbols mean that you shade above the line. So our solution sets, similar to when we were just graphing a single linear inequality, are going to be a shaded region. It's the double shaded region, that overlap. So in this particular case, this area in the purple, this whole thing in here, any point that's in this region here is a solution to that inequality or that system of inequalities. So we're going to graph each inequality in the same coordinate plane, and then we're going to find that overlap shaded region, and that's going to be our solution. Sometimes there is no overlap shaded region. In that case, there's no solution to the system of inequalities. So we're looking for that double overlapped area. So let's take a look at the first example. So my first example is y is less than or equal to 3. I know a couple things here. I know it's going to be a solid line. And I know because it's a less than, I'm going to shade below that line. And the line that I'm graphing is really y equals 3. And y equals 3, hopefully you're saying to yourself, is a horizontal line. So I have a horizontal line at 3. And I'm going to shade below that line. And I like to use little like diagonal kind of things here, and you'll see why. It makes it nice and easy to see where that shaded overlapped region is. So there's my first line, and I shaded below that. Now for my second line, which I'm going to graph in blue, I have y is greater than x plus 2. So I know that this is going to be a dashed line. I know I'm going to shade above the line. And I know I'm really graphing the line y equals x plus 2. Y equals x plus 2 has a y-intercept at 2. And the slope is equal to 1, or 1 over 1. So now I can go up 1 over 1, up 1 over 1. And I can go down 1 and to the left 1. And you want to make these lines as long as possible. I know it's going to be a dashed line. And in this particular line, I'm shading above. And it's very important to be neat when you're doing these. So I'm going to do this in green. I'm shading above this line. Green, I want a green. There we go. So what I'm looking for is I'm looking for that overlapped region where I have that double shaded area. And we like for you to circle that overlapped region. So where I have that red and the green shading in is right in this area in here. And there is my solution set for this particular equation, or this system of inequalities, I should say. So for example, you might be asked to actually name a couple points that are solutions. Well, the point negative 6, 0 would be a solution. Oops. So if we think about some points that are solutions, I can see that this point right here, negative 6, 0, is a solution. The point over here, 6 comma negative 2, that is not a solution, okay? It needs to be in both the overlapped region in order for it to be a solution there. And again, any point that's in that double overlapped region, that double shaded area, is a solution to the system of inequalities. Let's take a look at our next example. So first thing we have to do is we have to get these into y equals. So we're going to look at our first equation, which is 2x plus y is less than negative 1. So I'm going to subtract my 2x from both sides, and I'm going to get y is less than negative 2x minus 1. I know it's going to be a dashed line. I know I'm going to shade below. So I'm starting at my y-intercept of negative 1. Slope is negative 2 over 1, so I can go down 2 and to the right 1. Or I can go up 2 and to the left 1. And it's going to be a dashed line. I'm shading below this line. So I'm shading in this region down here. My second line, let's take a look at that one. 2x plus y is greater than 3. Going to subtract the 2x here. And I've got y is greater than negative 2x plus 3. Notice these lines have the same slope. This is going to be a dashed line. And I'm going to shade above. So once again, starting at my y-intercept, which in this case is positive 3. Slope is negative 2 over 1, so I can go down 2 and to the right 1. Or I can go up 2 and to the left 1. Notice that these lines are parallel. This is also a dashed line. Oops. This point should be right here. I'm going to shade above this line, which would be in this area, or this region up here. Notice that there is no overlapped region for this system of inequalities. So this system of inequalities, this is a case where we have no solution. There is no point that satisfies both of these inequalities at the same time. There are points that work for just inequality 1. There are points that work for just inequality 2. But there are no points that work for both of the inequalities that are shown here. We'll look at the try these in class. Let's look at our next example, where now we're given the graph and we're asked to write the inequality that is shown. So we want to start by writing our first inequality, which is going to be this one here. So we're going to write inequality number 1. This is a horizontal line. We see that it's a horizontal line at negative 2. So I know it's going to be y is something to negative 2. The equation would be y equals negative 2. But I'm not sure if it's greater than, less than, greater than or equal to, less than or equal to. I know it's a solid line. So because it's a solid line, I know my choices are either greater than or equal to or less than or equal to because it's a solid line. And if I look at the shading, I can see that the shading occurs not down here, which would be less than or below the line. It's occurring above the line. It's occurring in this region over here. So I know it has to be a greater than symbol, and it has to be greater than or equal to 2. My second equation, or my second inequality, I should say, is this line right here. I know it's going to be a dashed line. So I know it has to be a less than or a greater than symbol. And I can see that the shading is occurring below this line. So I know I'm going to have a less than something. So I know y is less than something. Well, what do you need to write the equation of a line or an inequality? You need the slope and you need the y-intercept. So we have to identify the slope and the y-intercept of our dashed line. We can see the y-intercept occurs right here. Where does it cross the y-axis? It crosses the y-axis at 0. In order to find the slope when you're given a graph, the easiest thing is to do rise over run. So pick 2 points on your graph and determine what the slope is. Well, I go up 1, and I go right 1. So my slope is just 1 over 1, or 1. So if we think about the equation of the line would be 1x plus 0, or just in simpler terms, y equals x. We know that it's a less than symbol because I have a dashed line and I've shaded below. So my my inequality would just be y is less than 1x plus 0, or in an even simpler way to write it, y is less than x, or 1x. So to write it all nicely in the same colors, our system of inequalities here would be y is greater than or equal to negative 2, and y is less than or equal to, not less than or equal to, just less than x. So you want to go step by step here. And you want to think to yourself when you're given the graph, which is probably going to be the most challenging part of this lesson, is it a dashed line? Is it a solid line? Did I shade below? Did I shade above? And then determine what the slope and the y-intercept are and think in terms of the equation when you're writing the lines. Let's look at this example. A little bit trickier example here because one of our lines is a vertical line. So if we look at our first line, which I'm going to label right here as line number 1, we know it's a vertical line. Vertical lines, remember, are always x equals. okay? And it's x equals whatever the value that is crossing the x-axis. In this case, it's x equals 3. But there's shading involved here. I know it's going to be a solid line, and with a vertical line, you can't really shade above or below. So we want to think to the left and to the right. Left corresponds to below. Right corresponds to above. So if I'm thinking here, I know I shaded to all the numbers that were below 3. I didn't shade to the numbers like 4 and 6. I shaded to the numbers like 2 and 1 and -1. So I shaded below that line, or less than that line. So my first line is going to be x is less than or equal to 3. I know it has the equal to symbol because it's a solid line. Now I have to graph my second line, line number 2. I know I'm shading above this line. I can see that my shaded region is up in here. So I know it's going to be a greater than symbol, and I know it's just greater than because it's a dashed line. So I know I'm going to have y is greater than something. What do I need to do now? I need to identify what the y-intercept is, which is right here. So my y-intercept is -1. And I need to identify the slope. So if I take a look here, I know I have a point here, and I know I have another point here. In determining the slope here, I go up 1, 2. So I went up 2. And I went over to the right 1, 2, 3. So I went right 3. So my slope of my dashed line is 2/3. Let's put it together. Y is greater than 2/3 x minus 1. And there is my system. So you have to be, competent in determining equations from a line. Very important stuff. Once you can determine those, or the equations from a graph, turn them into inequalities, and then go ahead and create your system. We've got some try these in class, as well as example 6, which we'll look at in class as well. If you want to take a look at it and try it ahead of time, feel free. We'll see you then.